Alright, let's get started. Alright, so guys, so congrats finishing milestone 1. Today we're going to be looking at some new advancements in Catbook on modernizing it. And by modernize, I mean we're going to add some new functionality and then go back and rewrite some of the code to be some more modern JS style. And I'll show you guys what I mean by modern JS style in a second. So here's the code that I wrote, so just remaking some Catbook. This is not a workshop, you won't actually have to write any code, but just in case you want to follow along with the things I'm going to be showing, you can clone the new Catbook from here. Alright. So today's agenda, we're going to be doing a few different things. So the first thing we're going to be going over is sockets in the library called socket.io, which is going to let us send things in real time, and I'll demonstrate soon what that means. We're going to go over something called promises, which is going to make asynchronous things a bit nicer. Take a little aside on a function called map, and then overall put these things together to make a new, fancy, modernized feed.js. So let's start with WebSockets. So here's Catbook currently. There is one flaw with Catbook that's pretty glaring. So when you type a message and you hit submit, it just kind of goes away. And you have to refresh the page in order to get it to appear. It would be nice that if you type something and you push submit, it just appears right on the page. This part of it is pretty simple. You guys can probably have the knowledge to do this. Does anyone know how you can make this happen? Yeah.
Add an additional event just to make a GET request of the thing you just posted.
You could send out a GET request, but if you're just doing it, if it's only on your computer, you've already type the information, you don't need to send another request. You just take this string, you make a new comment object, and you just put it on the screen. So yeah, you push submit. At the same time as you post this to the server, you also make a new comment object and simply append it to the screen. No networking really required here. That's pretty straightforward. But say it's not just me. I have my Catbook open, and then my friend Tom also has his Catbook open. So say I type this message and I hit submit. I want it to appear on my screen without refreshing, and also Tom's screen without him refreshing either. And Tom is off somewhere else on a different computer. Now this is a lot harder, because I need to tell Tom over the network that I just made a post. So how do we do this? Let's try to visualize this problem. So here we got Fluffy, he's on Catbook. He's joined by his two friends, Whiskers and Jeff. So Fluffy's going to make a post to Catbook. What that does is it makes a post request to the server. Now the server needs to notify Whiskers and Jeff that, hey, there's a new post. Please display this. So can we just do this? Can the server just say, hey, post this thing? Turns out with HTTP, with what we've learned so far, there's not really a good way to do this. Because in HTTP, the way we always do it is the client sends a request to the server and then the server responds. But here we just want the server to straight up send data to the clients without any request being initialized. So this is kind of a limitation. You need to initiate, the client needs to initiate by sending a request before we can get any data back. So the server can't just send data of its own volition whenever it wants to. It needs to wait for a request to come in before responding. It's kind of limiting in this way, but there is one workaround that we can think of, and it's just repeatedly ask the server. So let's set a timer for every 1 second. Every second, Jeff is going to ask the server with a GET request. Is there any new posts? Nope, not yet. Any new posts? Nope. Any new posts? Yes, Floppy just posted something. Put it on the screen. This works fine. It will update this page without needing to refresh. It is kind of sketchy though, because you have to just kind of spam the server with requests every second. And there's got to be a better way to do this. It turns out there is a nice better way to do this. Not with HTTP, but there's another protocol called WebSockets. And what WebSockets will do is it allows full duplex communication. That means in 2 directions. So the client can send requests to the server, like with HTTP, but the server can also send data to the client whenever it wants to, at any time. No need to wait for a request. So this eliminates the need for polling, and it's a much cleaner solution. So we'll basically work under the hood, and we're going to have a library do this for us. But Jeff is going to basically say to the server, I want to upgrade and use WebSockets instead. And the server's going to be like, all right, now you're connected. This is like a handshake that says, okay, we're ready to do total bi-directional communication. And now that we can send in both directions, the server is free to send messages to Jeff without ever needing to wait for a request to come in. So it can say, hey, Fluffy posted something. Whiskers just commented. And Jeff is going to automatically display this on his page without refreshing. So let's go through the whole pipeline now. So WebSockets are connected. Fluffy sends a post to the server. The server is going to use WebSockets and push a new story to Whiskers and Jeff. And this is going to be just as simple as that. We're going to use a library that's going to make this really easy. It's called socket.io. It's a real-time library and it uses WebSockets underneath. It abstracts out some of the hard stuff like figuring out how to connect, and it provides you nice functions like the ability to broadcast to everybody who's online. And we're going to be using that broadcast ability today. So here's the basic usage. On the basic level, socket.io is two commands. Emit, which sends a message to everyone, and on, which is like an event listener. So when you say on message, I want to run this callback function. And notice we provide a type. So type can be like, I'm sending a message of type story or of type comment. Type is just a string, whatever you want it to be. And so Jeff is going to be running, for example, on story. I want to take that story data and put it on the screen. Let's practice to make sure we know exactly what emit and on are doing. So let's say we have a class. We have Bill Strang here and his students. They're all connected up by WebSockets. The professor wants to send out a pset to his students. So what does he do? He wants emit. He emits pset and that broadcasts it to all the students. So how do the students know what to do when they get a pset? Well, in their code, they've defined an on function. So on pset, they're going to run a function, and their function is start working. If you want to actually write this in socket code, it might look something like this. So the professor's going to emit a pset, and along with emit, you provide some data. Like, oh, it's due this day, you have these questions, solve easy stuff, what is PWP? The students define an event listener. So on pset, when I get a pset, I'm going to run this code. I'm going to procrastinate forever and eventually try to solve it. That's simple. There's two commands. And let's go back to Catbook. What does this mean correspondingly? So the server, when it receives a post request from somebody, is going to emit that story, which will broadcast it to everyone who's online. Then everyone who's online is going to have to find this on callback, which just says, when I get a story, I'm going to put it on the screen without refreshing. Alright? So here's the changes that I made to app.js. You don't have to actually type anything, but if you want, you could follow along in the repo if you so desire. So there's only a few lines in app.js. You just require socket.io. It requires npm installing, just like everything else we've been doing. const.io, you basically just initialize your socket, and then app.set, which basically serves or saves this socket instance in our application so we can retrieve it and use it later on. Yeah. So, and then we're correspondingly on the front end, we also need to include it, just like including API, including feed. Socket.io library will automatically serve the socket.io.js on your server at this location. So all you need to do is simply include this link into index.html, and now both the front end and back end have socket code loaded. So now let's go back to our code. This is exactly what we had in Workshop 4. Just in case we don't remember, let's go through this really quickly. So this is what happens when you post a story. So the first thing it's going to do, after making sure you're logged in, is use the story model to make a new story document. So a story requires an ID, a name, and content, which gets set here, and then we're just going to save it, which will upload it to the Mongoose, upload via Mongoose to the Mongo database. And then once this succeeds via this callback, remember we wanted to do an additional thing where we find the user that posted this and say, this post was the last post they made, so we can save it on their profile page. And then, in the end, if there's any errors, we print it out and then we return. Now, let's modify this code very slightly so that in addition, it also sends a socket request. So we get a story, we've saved it to the database, and now we want to use emit And remember, emit means broadcast. You send it out to everybody who's connected. So that means if Fluffy just posts it to the server's going to see this and then emit it out back to Whiskers and Jeff to let them know that there is a new post. And the story right here, so I thought I made story. The first story is the type. It's just a string. It's saying this message is of type story. And then the second one is just a JavaScript object. Just a bunch of JSON that corresponds to that story. And then, correspondingly, on the front end, let's see what we need to add. So here's our index.js that we wrote before. Quite simple. All it does is log you in and render the navbar, render the stories. We did this last week. How do we modify it? Just add these few lines. Const socket. The IO function is something that just returns to you the socket.io instance we're using. And now we just add our on function. So on story, we're going to run these 2 lines. If you remember from workshop 1, this could be familiar, because all we're doing is we're going to get the story div, which is the div on the page that contains all the stories, and then stick a new story in there. So story.object is a function that just makes a new story with the JSON object stored here, and then sticks it onto the page. It's all it's doing, 2 lines. And the same thing for comments. It's almost exactly the same code. When somebody posts a new comment and you save it to the database, you emit it. But this time using type comment instead of type story. And in public.index.js, same thing. On comment, make a new comment DOM object and stick it on the screen. Just 2 lines. All right. And that's it. That's all there is to using WebSockets on a basic level. You emit things to send them out, and use on to say what you do when you receive the messages. There's some other things I didn't quite mention, like you can emit to specific people. Like you don't have to broadcast to everyone. If you only want to broadcast to cats with blue fur, you can do that. I'm not going to show it today, but check out the docs if you're interested in doing that. So next, we have reached promises, which we're going to use to make our async code a bit nicer. So before that, I want to preface this by talking about JavaScript and its changing nature. So JavaScript has been around for like 20 years, but it hasn't been the same the whole time. So there is a specification called EMCA script. It's called ES, and that's just basically dictates what features should JavaScript have. And every year or so, there's a new ES version, which introduces new features into the JS language. One of the biggest updates was called ES6. You might see this around on the internet a lot, but this is basically a significant change to JS, which introduced some new features. So what's new? One thing we've already been using from the ES6 updates is the keywords let and const. In old school JavaScript, you would just use var for everything to define your variables, but now we're using let and const to make things a bit nicer. There's another for loop syntax in JS introduced by ES6. So the top one is the one we've been using, but you also have these Python-style for loops that we haven't actually mentioned yet, and they're quite nicer. So this top line is exactly the same as the second line. You can do for I in array, and that goes through all the indices of the array. Not to be confused with for I of array, which the distinction is kind of subtle. If you look at that print statement, instead of going through the indices, it goes through the actual objects inside the array. It's kind of confusing to get these mixed up, but just so you're aware in case you encounter this, there's a difference. Another important function is the arrow functions. We mentioned this last week, but in case you forgot, there's an alternate kind of shorthand syntax for defining functions. Instead of using the function keyword, you can just type your parameters and use this arrow symbol, which will define a function for you. And I'm going to be using this a bit today too. So first, can I use ES6? So ES6 is like a modern, well not too recent, it's like 2015, but it is a relatively new addition to JS. And if you're using an old browser, say if you're using a browser from 2014, in that case, there's no way that you'd have these updates because the browser was made before these new additions to JS were made. Nowadays, it's 2019, almost every modern browser supports ES6 except for IE, which is not a modern browser to be honest. But in the past, the way you get around this is by doing something called transpiling. So if you know what compiling is, so For instance, if you have a language like C or something, if you have this human-readable C code, and a compiler is necessary to take this code and turn it into machine code that is understood by the computer, but basically unintelligible to humans. So this is the process of compiling. There's another one called transpiling, which takes one human-readable format and converts it to a different, also probably human-readable format. So it is possible to transpile JS, take it from this new style ES6, and basically translate it into old style ES5 code. So, like for example, if you have these new fancy for loops in your code, you run it through a transpiler, it automatically replaces this with the old style, like for var I equals 0, I plus plus, whatever syntax for you. There's some tools to do that. Nowadays, it's not really that necessary unless for some reason you want to support IE. But yeah, just as a note. So let's preface this by talking about some motivation for what we're going to do. Last year, we talked about callback help. So what this function does is it says, get thing 1, wait for that to finish. Get thing 2, wait for that to finish. Get thing 3, etc. We remember that chaining things that are asynchronous using callbacks is kind of a pain because you need to nest them. And it quickly gets out of hand if you want to do a big sequence of things. But we're going to introduce promises which will let us get around this. So remember, this is the syntax we've been using this whole class. Get the stories, and then when it's done, it returns a callback. All right, we've been doing this. But there's a new syntax, and it's going to be promises. So look, check this out in the bottom. So get the stories, and it's going to return something. It's still asynchronous, it's going to return right away. But this object is going to be called a promise. So what the heck is that? So a promise is an object that's going to keep track of the current request that's ongoing. If you print out the promise, it's going to say either this request is currently pending, and then if it's finished, it's going to have either two states, resolved or rejected. If the request succeeded, it's going to be resolved. If an error happened, it's going to be rejected. And with promises, you can actually specify what it should do when it resolves or rejects. So here's basically how to use a promise. So I want to get API/stories, and it's going to immediately give us a promise. See this then function. So promise.then, print out the stories. So all this is doing is we're going to get stories, and then when it's finished, run this callback function and do whatever you want with it. There is another one called catch. If you've seen catch from like Java, for example, it's used to handle errors. Python, this word is accept. But basically all it does is if there's an error in the process of sending out this GET request, it's going to fall down to this catch block, which will do some things to like recover from the error. So it might print out to the user, oh, something happened, we couldn't process your request or something. So yeah, very important that, okay, yep. And you can also format it a little bit differently. You'll usually see it a bit more like this. Instead of defining the const as a promise as a variable, just directly stick the .then on the end of this request. And so it looks something like this. So get stories, and then run this up. And if it exploded, say something exploded. All you really need, oh yeah, and you can also use arrow functions. Remember, instead of using the keyword functions, just replace this with a nice arrow, and it's a nice shorthand that we'll be using. So the main takeaways from this part is I just want you to remember there are two main functions that you use when you do promises. It's .then, which gets run when your code succeeds, and .catch, which runs when your code fails. So let's make sure we understand. Let's go back to our example from before. So I'm doing my pset. I run that function, it returns me a promise. So this promise will either resolve or reject. If it resolves, that means I did my pset successfully. If it rejected, that means some error happened. Maybe I just totally gave up and threw out my pset. And once it finishes resolve, remember it runs a then function. So I finish my pset, and then I'm going to hand it in, or do some other actions. There's another one called catch, which is what we're going to do when I fail to do my pset. So if I give up, catch it, and then drop the class, or do something. So yeah, two things, then and catch. In code, it might look like this. Do pset, and then, if it succeeds, hand it in. Catch an error. If I screwed up, screw it, drop the class. So one more time, then and catch. All right. So next, let's introduce something kind of magical that you can do with promises, and that is chaining these then statements. So this part, see, we get the stories, it returns to you in the top then block, and this then block is going to return the first index of stories. All that does is pass it on to the next then statement. So it passes it on to the next then, which will get that first story you printed out. Why is this useful? This might be useful because you can kind of modularize your code into multiple then blocks, and it's kind of handy if you want to split it out into a function like this. So here's that first part of the code, this top 4 lines, I put it into a function. I kind of actually crunched it to be on one line, if you notice this slick arrow function at the top. You can actually omit the return statement when you have it all on one line like this, just as a note. So yeah, this is exactly the same code we wrote, except we extracted the top 4 lines into get first story. So now whenever you call this function, this returns to you a promise. And when that promise fulfills, it'll give you just the first story that's in the database. Perhaps something more useful for chaining though, is you can chain promises themselves. So we call get first story, and it returns to us the first story. Now let's say I want to get all the comments for that story. Get API/comment, and the parent is that story. And if we return this promise, what JS will do is it'll wait for that promise to be fulfilled and then go into the then statement. So then that'll print out all the comments. Remember, if we were doing this with the callbacks from last week, we would have needed to put this get callback within the other get callback, and there would be like a 3 layers deep index. But here, it's a bit prettier. It's all pretty flat. And so once we have this example from last week, the way we promisify this is just trash. We just do this. Really nice. See, so we get thing 1, and then we return a new promise for thing 2. Every then block goes another request. These will all be guaranteed to execute one after another, and you avoid having to get 10 layers deep in tabs. So that's some of the power of promises. There's one more fancy thing that I'll show to you. It's called promise up all, and basically all this does is it takes a bunch of promises and squishes it into one. So I'm going to fire these 6 get requests all at the same time. The promise up all will say when it's going to return when all 6 of those get requests successfully finish. So the lines at the bottom will say, once all my get requests have finished, I'm going to run this callback function. So now we go back to our backend that we wrote before, and let's add some promises to it. All right, this is the same code we had about 10 minutes ago. But once again, we make a new story, we save it to the database, and then we update the user's last post. And it turns out that Mongoose will support promises for you. So instead of putting stuff inside callbacks, we can use .then. So let's see what this looks like. So new story.save, and then we're going to run this stuff we had before. We're going to emit it via socket.io. And then the next thing we're going to do is we want to fetch the user so we can update its last post. I did this here by chaining promises. So I said return user.find1. And user.find1 returns to you a promise. And when this promise fulfills, it enters the second then statement. And this passes to us, the user. We set its last post and we save. And if anywhere between those 2 steps an error occurs, the code, what it's going to do is drop down to this catch statement and just print out an error occurred. So it helped a little bit. Instead of having this multiple lines of indentation, we had to indent for new story, indent for find one. If we had to do a third command, it would indent again. But this is nice. It's quite nice and flat and more readable is the main thing. So let's revisit API.js. Don't bother reading this code. It's really hard to understand. It's long and confusing. Remember, this was our code that we used to send a get and a post request. This was on the front end. Remember, we talked about something, XML, HTTP request. It's like really hard to understand, does some things that are unintuitive, and it also doesn't use promises. Now, it turns out that JavaScript has another tool built in. It replaces XHR, which has been around for like 20 years. It predates Chrome, it predates Firefox. But there's this new tool called Fetch. And it sends out HTTP requests and uses promises. This is all you need to type. Fetch should already be defined if you open up your console and just type fetch. It should be a function. So say fetch API/stories, and it's a promise. When you go .then, it'll send you a response. And you can turn that response into JSON by using its built-in .json function. And if the request fails, you can use catch, like we've been talking about before. Quite simple. So here is the new API.js. I shortened it. It's about only a third of what it was before because we're using fetch now. If you look at Catbook Modern, I've updated the API.js. Feel free to steal this code because it's nice and concise. So you just fetch a GET request, and I changed something just so it will return JSON instead of returning like what it normally does, just so we can be consistent with what we had before. Post request, a little more involved, because you have to actually explicitly say, this is a post, and you have to explicitly tell the server that what I'm sending is JSON. So that's just an important little thing to detail to go through. But overall, short and more concise than dealing with the old style XHR. All right, so that's it for promises. Any questions about how promises work or fetch that we talked about? All right. So now let's take a quick detour and talk about something called map. It's nothing too fancy. It's not even an ES6 feature. It's been around since ES5, I think. But we're going to be using it later today too. So I figured we'd just make sure we understand it. So map, what it does, it requires an array and a function. Two things. And all it does is it applies that function to everything in the array. So let's say our function is x times 2. We apply the function and we get a 2 out. We apply the function 468, simple. And what this mapping procedure does, it returns this array on the right, 2, 4, 6, 8. That's all it does. If the function was x minus 1, returns 0, 1, 2, 3. And then let's write this in JavaScript. Using map, we have our array, 1, 2, 5, 7, in their function, which is x times 3. So if you run the map procedure and you print out the result, unsurprisingly, we're going to get 3, 6, 15, 21. That's all mapping does. It takes this function and applies it to every element, and it returns to you a new array. Here's one way we can make it shorter. Remember using the inline arrow function syntax? I wrote that whole function on one line here. X goes to x times 3. Same thing as saying function x, return x times 3. Right? So that gives you a new array. That's all there is to map. Just wanted to make sure we understood that before I go into the final part, which is going to be modernizing public/js/view.js. And it's going to put together everything we learned today. So let's recap on what render stories does. This is the new version. I'm going to go through it line by line because it's a lot to process. But what this function did before was, all it did was send out a GET request for the stories, put them on the screen. Send a GET request for every comment, and put them on the screen. And I've rewritten it here to use fetch and promises. So the first thing, this is the first part, same as before. If the user is not undefined, all that means is if the user is logged in, display, new story. Okay, now I'm going. So const stories div. So this is the first thing we're going to do is get the div that contains all the stories on the page. It's just ID equals stories. And this is the thing that when we make a new story, we just want to stick it into the stories div. So the first thing, we're going to get API/stories using promises. So instead of passing in a callback as before, we're going to run a .then. And when this .then comes, we want to iterate through all of these stories. Note we're using an arrow function here. But using the for loop, this Python-style for loop, we're going to go for story of stories. So this does the same thing as it did before, but just for every story, we're going to run this function. And it's going to make a new story.object and put it onto the page. And now look at this big line we have here. Let's take this into pieces. So what this line does is it's going to make a promise for every story, get comment for every story, and then wait for all of them to finish. So this top line, this top code is equivalent to the bottom code. This is what map does. Or if you remember, it's going to make a GET request for every story and push them onto a list of promises. And it's going to wait for every promise in that list to complete before it moves on to the final then statement. And then responses, what it's going to do is return to you basically an array of arrays. So it's an array where every index corresponds to like get request 1, get request 2, get request 3. And every get request gives to you a bunch of comments. So that's why we need this 2D for loop here. So the outside one, we're just going to iterate through all of the get request responses we got. And for each get request response, iterate through every comment we got. And then just as before, make a new comment down object and put it onto the screen under its corresponding parent. All right, so that's basically everything we got through. We got through WebSockets and promises. If you were doing something, a project that's going to involve like something real-time, like a chat room or a game, you're probably going to need to use sockets or socket.io. So something important to understand. And for further reading, you can check out these links to learn more docs about fetch and promises, because there's plenty of things that I didn't have time to mention. And if promises aren't cool enough to you, there's another thing called async and await, which I'm not going to talk about today, but basically it builds on top of promises and makes it even more cool. It's really modern. It's like ES8 or something. But check this out if you're curious about what some cool modern JavaScript is. And that's all I have.